Hi, Assalamualaikum. Today we are going to present about experiment 3 measuring gravitational acceleration. We have 4 members in our group. The first one is IRFAN SYAHMIE, ASHRAFF HAIQAL, FAHRUL and AZAMUDDin. Okay, first of all is introduction. This lab report explores the concept of gravitational acceleration. The report will detail the experiment conducted to measure the acceleration due to gravity and the results obtained. This report will also discuss the implications of the results and any possible errors in the experiment. Furthermore, the report will explain the assumptions made in the experiment and the limitations of the results obtained. Finally, the report will conclude with any suggestions for further research or experiments related to the concept of gravitational acceleration. The next one is theory. Gravitational acceleration is the acceleration of an object falling freely in a vacuum. This is a constant increase in speed caused by the pull of gravity. If a body of mass is accelerated from the state of rest in a constant gravitational field, it performs a linear motion. In a vacuum, all bodies accelerate at the same rate, regardless of their mass or composition. Gravimetry is the measurement and analysis of these rates. There are two objectives in this experiment. The first one is to investigate the functional relationship between height of fall and falling time. The second one is to determine the acceleration due to gravity, g, by studying the motion of a freely falling body.
These are the apparatus needed. Falling spear apparatus consisting of release unit, impact switch, digital counter, 4 decades, support base, right angle clamp, plate holder, meter scale, support rod, connecting rod, and ball bearing. This is how we conduct the experiment. This is how we conduct the experiment. Let's move on to the procedure. First one, the apparatus was set up as in this picture. The release mechanism is grip in the release mechanism which close the start circuit. Second, under the arrest switch, the pen was adjusted using the screw under the arrest switch. That was such a way that a downward motion of a few tenths of a millimeter closed the stop circuit. The pen was raised by hand after each single measurement. Third, use the marking on the release mechanism for getting the effective determination of the height of fall. The radius of spear must be taken into account. Diameter 3 quarter 4 inch, approx 90 millimeter. The aerodynamic was neglected.
The table shown is the result that we get from the experiment. The first graph is the graph for height of fall as a function of falling time. The second graph is the graph of fall as a function of the square of falling time. For our analysis, first one is centroid. The centroid that we got from the second graph is 0.0456 at the x-axis and 0.275 at the y-axis. For the uncertainties of gradient that we got is plus minus 0.5275. The value of uncertainties of the gravity is the plus minus 1.055. And the last one is the percent error that we got is 15.8%.
Lastly is conclusion. Falling sphere apparatus was used to investigate the functional relationship between height of fall and falling time and obtain the required data for the experiment. The apparatus such as falling sphere apparatus consisting of releasing unit, impact switch, digital counter, 4 decades, support base, right angle clamp, plate holder, meter scale, support rod, connecting cord, and ball bearing was used to achieve the objective of this experiment. Based on the law, it is stated that the height is directly proportional to the square of time. The experiment conducted proved the law that was used. By the end of the experiment, it is concluded that the height increased and also square of time increasing.
Thank
Thank
you
Thank
you.
you
for
for
watching.
watching.